Now, this other problem is one of those problems that I like a lot, that are just when we have to compare two magnitudes, right? You know, what happened when we change the magnitude or the value of one of the physical quantity, the magnitude of one of the physical quantities involved in a given phenomenon. So they say here, and the key to understand this problem and to solve this problem successfully is to read it carefully. They say a mass mu sub zero is attached to a spring that hung vertically. So we have this spring that hung vertically, and we have this mass m sub zero attached to it, right? They say that the mass is raised at a short distance in the vertical direction and release it. So they will push this system up, you know, and they will release it. And then the mass is going to be oscillating with a frequency f sub zero. They say, well, if now I replace the mass with a new mass that is 9 times as large as the initial mass, so if I have now a mass mu prime that is 9 times mu sub zero, m sub zero, I say mu, sorry, m prime, which is 9 times m sub zero, so mass prime, which is 9 times the mass sub zero, the initial mass. What would be in this case the frequency of the oscillation in terms of f sub zero? So what is going to be, what would be in this case f prime, you know, as a function of f sub zero? This is what they want. So what I know that for this system, you know, where I have a frequency f sub zero and I have a mass m sub zero, I know that the expression for the frequency is this. I say the frequency sub zero is 1/2 pi times the square root of the constant of the spring divided by the mass m sub zero, m sub zero. Now, if I do the same thing for my system after adding the mass that is 9 times the initial mass, right? So if we now find f prime, s prime would be 1/2 pi the square root of k over m prime. So the frequency prime, so the frequency after the event of adding 9 times a new mass that is 9 times the initial mass will be 1/2 pi times the square root of the constant of the spring over the mass prime. But I know this mass prime is equal to 9 times the initial mass. So I know that this frequency f prime would be 1/2 pi the square root of k over 9 times m sub zero. Of course, now we're going to do some algebra, very simple algebra. So we say 1/2 pi square root of 1/9 times k over m sub zero. I will find the square root of 1/9. So this would be 1/2 pi times 1/3, which is the square root of 1/9, square root of k over m sub zero. So now we will say that f prime would be 1/3. I will reorganize my factors. 1/3 of, you know, 1/2 pi the square root of k over m sub zero. And this 1/2 pi times the square root of k over m sub zero, this is my frequency sub zero. So I can say now that f prime, the frequency prime, will be 1/3 of the frequency sub zero. So I found with this that when I increase 9 times the initial mass, the frequency of the oscillation will be reduced to 1/3 of the initial frequency, right? So the frequency of the oscillation will be reduced to 1/3 of the initial frequency. So imagine that I had a frequency of 9 hertz, right? So I had 9 oscillations in the unit of time, the 9 oscillations in a second. Now, after adding a mass that is 9 times the initial mass, I will have just 1/3 of 9 if my frequency was 9, so it would be now just 3 hertz. But we have only 3 oscillations in the unit of time. So this is what, this result means really.